Okay, so we are on, we're still in 5.2, which is a very difficult section. That and the exponential growth are probably the two most difficult sections. And we're on problem number 11. Number 11 is a bit of a pain because you've got an x to the fourth, a fourth degree polynomial, which means if I find a rational zero and then therefore I find a factor, if I divide that factor into this degree 4 polynomial, I'll be left with a degree 3. What do you do with a degree 3 polynomial? How do you find the zeros of that? Well, you got to look for a zero, make a factor out of it, divide it in again. So I'm going to have to do 2 rounds of this. Okay, that's really annoying. But, you know, life's difficult sometimes. Another option would be, let's see if I can find 2 different rational zeros, and there's a way to divide them both in at the same time. Like, for example, if let's say I had the number, just as a quick little look ahead. Suppose I do like 2 times 3. Let's just look at numbers for a minute. 2 times 3 times 5 times, I guess, 7. Okay, so what would that be? 6 times 5 is 30. 30 times 7 is 210. So suppose I told you to factor 210. So suppose you say, well, let's see. If I tell you to factor 210, suppose you say, well, I know 2 goes in to 210, and I know 3 goes into 210. What's the remaining factors? Well, you can multiply them, right? That means 2 times 3 goes in. So if I divide 210 by 6, that means I'm doing 2 divisions at once. I'm dividing it by 2 and by 3, okay? And guess what I'm going to get? I'm going to get 35, because I'm removing this, right? So if I remove 6, I should get 35. Right, do I? 35 times 6. 30 times 6 is 180. 5 times 6 is 30, so you get 210, remainder 0. In other words, the idea is if you know 2 factors, if there's 4 factors in a quantity, and you know 2 of them, you can multiply those 2 and divide that product, the multiplication, divide that in to the original number, and that will give you the remaining amount if both of these factors were divided in individually. So instead of doing 2 separate long divisions, you only do 1. Okay, so I'm going to try to do that here just to save myself a round of work. Okay, this is when you have, you know, a higher degree like this. So let's go ahead and do a little bit of work here. So if I use the rational zeros theorem, what are the potential rational zeros? It's going to be a huge list, but at least it'll give us a place to start. We're going to have what? Factors of the factors. That's factors of the constant term divided by factors of the leading coefficient. So the constant term is negative 60. So that's going to be 1, 2, 3. Whoops, plus or minus 3. 4 goes in to 60. 5 goes into 60. 6 goes into 60. It's getting pretty annoying already. Does 8 go into 60? No. 10 does, right? 12 does, because 12 times 5. 15. 30. And we're not even done yet. And then 60, right? So plus or minus 30. And then plus or minus 60. That's huge, okay? On the bottom, I've got the 48. That's a lot of stuff. 1s, 2s, 3s, 4s goes into 48. 5 does not. Does 6 go into 48? 6 times 6 is 36. And then another 6 makes 42, and another 2 makes 48. So, yep. Okay. 8. Yep. What about 10? No. 12. And 24. How about 16? 16 times 3, right? And then 24. This is huge. I mean, so each like 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 6, 1 over 8, 2 over 1, 2 over 2. In other words, it becomes a huge list. You have to take each of these and divide by each of these. You'll get some repeats that you can cross out, but it's still going to be a huge list. But at least I know what the potential denominators are. Okay? So let's go ahead and put the function in. Okay, and I've already got it in there just to save a little time. 48x to the fourth minus 232x to the third plus 123x squared minus 163x. And then let's see if I can scroll over. And then make sure I typed it in right, minus 60. Yep, okay. So that's in there. Now, I want to first look for whole number rational zeros. So the way to do that is go to table set and make sure you're starting at 0 and going by ones. When you go by ones, you're plugging in whole numbers. Let's make a table. See if we see any whole number. Oh, bing, I've already got a whole number 0. Okay, at 4. Notice that's in the list. 4 over 1. 4 over 1 is 4, and there it is in the list. When x is 4, you get a 0. Now, if I scroll further up towards bigger numbers, notice the polynomial is just becoming huge. If I scroll in the negative direction, it's becoming huge, which means I'm not going to see more zeros. Okay, so the only whole number 0 it looks like is just 4. So I already know x equals 4 is one of my guys, right? That's one of my zeros, which means x minus 4 is a factor. Now, we said the strategy here was to maybe find a second rational 0 before we go any further. So let's start looking at fractions. And there's a way to do that with the calculator. The first set of fractions I'm going to look at would be fractions with a 2 on the bottom. So 1 over 2, 2 over 2, 3 over 2, 4 over 2, 5 over 2. Now, of course, 2 over 2 is just 1, and 4 over 2 is 2, but the other guys are interesting, right? 1 over 2, 3 over 2, 5 over 2, etc. Okay? A way to plug in halves on the calculator is go to table set, start at 0, and plug in, go jump by a half, right? So 1 over 2. Now, of course, the calculator is going to convert 1 over 2 into 0.5, but that's okay. Let's make a table. Do I see any zeros? Okay, so the number 4 is a 0, but we already knew that. I'm looking for something with a half. So 1 half, 1.5 is 3 halves, 2.5 is 5 halves. I'm not seeing anything in the positive direction. What if I go in the negative direction? Do I see any more zeros? It looks like no, it's getting huge. Let's go down here. Make sure if I go in the positive direction, the answers are, I already knew that 4 was a 0. We already have that over here, right? So, but then the numbers are getting huge again. So it looks like the halves are a washout, okay? Let's try the thirds. Okay, let's try these thirds. I guess we'll go with a green here. Let's try these thirds. Okay, how do I do that? Go to table set, start your table at 0, delta table of 1 over 3. Okay, and it's going to convert that to 0.33. Now, don't just type in. A lot of people will just type in 0.33. Oh, a third is 0.33. That's only 2 decimal places. You need all the decimals. You always want to type in, when you're doing fractional delta tables, type in the fraction. Don't just make a decimal on your own. It won't be good enough. You have to type in the whole fraction. The calculator is showing you this, but internally it's probably got a whole bunch more 3's in there. Okay, so that's what we want. So now let's make a table. And notice, boom, 1/3, I've already found a 0. Okay, are there others with, in the thirds range? No, not in the negative direction. How about in the positive direction? Nope. Okay, so I have it right there. 0.3333 is 1/3, right? So x equals 1/3 is a factor. So that is a 0, I'm sorry. So therefore x minus 1/3 is a factor. Now, this is a factor with a fractional term. Okay, we don't want those. We want whole numbers. So what I'm going to do is multiply the entire factor by the least common denominator. The denominator of x is 1. The least common denominator between a 1 and a 3 is 3. So I'm going to multiply the factor by 3. And I get what? I get 3 times x is 3x. And then 3 times a third, 3 times negative a third is minus 1. So what the reason this works is because if I have x minus 1/3 as a factor, and I set that equal to 0 to look for the 0 corresponding to that factor, I'm going to get x equals 1/3, right? What if I had this? 3x minus 1 as my factor. What's the corresponding 0? Set it equal to 0. 3x equals 1, x equals 1/3, right? You get the same thing. Both this factor and this factor have the same 0. We'd rather use this version because it doesn't have a fraction, okay? So the idea is I already know that x minus 4 is a factor and 3x minus 1 is a factor. How do I know 3x minus 1? Because 1/3 was a 0. So x minus a third was a factor. Multiply it by 3 to kill the fraction. 3x minus 1 is a factor. Okay? What I'm going to do is I'm going to FOIL those out and get a polynomial with power 2 and divide that in to the original polynomial. Okay? Or I could continue my hunting game. I could try quarters, and then sixths, and then eighths, and then twelfths, and then sixteenths, and then 24ths, and then 48ths. I ran out of space, and then 48ths. That's, keep setting your table with those different delta x's to check those. But I'm just going to, at this point, I don't want to, that's a lot of hunting. I already have 2 results. That's good enough for me. I'm going to go ahead and FOIL them out and then do a division. Okay? So x minus 4 and 3x minus 1. So we already know x minus 4 was a factor. Whoops. And we already knew 3x minus 1 is a factor. So I'm going to FOIL them out. Okay? So let's do a little FOIL off to the side here. So x minus 4 times 3x minus 1. If I FOIL them, x times 3x is 3x squared. Outer times outer. Inner times inner. Last times last. So I have 3x squared minus 13x plus 4 as my product of these 2 factors. So that means if I divide the original polynomial by this, I'm essentially dividing it by both of these factors at the same time, like we discussed before. That's the idea. Okay, so let's go ahead and do that. So I'm going to say, okay, 3x squared minus 13x plus 4 divided into this big old monster, 48 x to the 4th minus 232 x to the 3rd plus 123 x squared plus 163x minus 60. Man, my hand's like falling off already, and we're just writing the polynomial. All right, how do you make a 3 look like a 48? You multiply by 16, right? How do you make an x squared become an x to the 4th? I need 2 more powers of x. Okay, multiply back down. 16 times 3 is, what, 48? Okay, now 16 times 13, well, let's see, 16 times 10 is 160, and then 16 times 3 is 48, so 160 and 48 is 208. So I'm going to have minus 208 x to the 3rd, and then don't forget that you got the 4 there, okay? So 16x squared times the 4 is going to be what, 64, and then x squared times no more x's is just still x squared. So now you get 3 multiplications when you bring it down, okay? Subtract the whole thing. So we're going to have a lot of subtraction here. Okay, if you want, you can convert it to, I guess I'll go ahead and do the conversion. I'll make it plus and change all the signs. Okay, so 48x to the 4th minus 48x to the 4th is gone. Negative 232 on those x cubed plus 208 is going to be what? So 32 take away, the 200s kind of wipe out. 32 take away 8 is what? 24. So it's going to be negative 24 x cubed. And then you're going to have, let's see, 123 take away 64 would be what? Was that going to be 59? Because 64 plus 50 would be 104. I'm sorry, no, plus, yeah, so because if I put a 60 in, it's going to be 128. Yeah, so 60, no, that's too much. So if I put in 50, 64 plus 50 is 94. You know what? It's 4 in the morning. I apologize. I know it's embarrassing. 123, take away 64. Yeah, 59. I was on the right track. Sorry about that. Okay, so we're going to have plus 59 x squared, and then plus 163 x, and then minus 60. And then, now, how do I make a 3x squared, squared look like a 24x cubed? Well, how do you make a 3 look like a 24? Multiply by negative 8, right? Because 8 times 3 is 24, and then I need another x. So negative 8x times 3x squared is negative 24, and the x squared times x is x cubed. Negative 8x times negative 13. So 8 times 10 is 80, and 8 times 3 is 24, so that's going to be 104. So plus 104 x squared. And then 8 times 4 is 32, negative. And we're going to subtract all that. So instead of doing a subtraction, which looks like a lot of work, I'm going to just go ahead and change the sign on this one and do a addition, plus, and then change all the signs. Okay, and so what do we get? We get negative 24 plus 24 is gone. Okay, so I'm going to have 59 take away 104 is negative 45 x squared, and I'm going to have 163 plus 32 is going to be, let's see, you're adding, so it's going to be 195 x, and then minus 60. And then lastly, how do I make a 3x squared look like a 45x squared? I need to multiply by what? 15. And it has to be negative to get the negative. Okay, negative 15, and then I don't need to change the x's anymore. We have to write a power of x. Now 15 times 3, negative 15 times 3 is negative 45. And then 15 times 13, let's hopefully see what we get here. We get 195, which is good. And then 15 times the 4 is negative 60. Notice that when we do the subtraction here, whoops, I guess I could have kept the same color, minus that, I'm doing something take away itself. So I'm going to get a 0 remainder, okay, which is good. That means we had the right factor and we did the right long division. Okay, so therefore I know that this polynomial can be written as x minus 4 times 3x minus 1, right, which together was this. By dividing by 3x squared minus 13x plus 4, which I got here, I'm actually dividing by both of those at the same time. Okay, and then times this remaining quadratic factor of 16x squared minus 8x plus 15. Now how do I factor that? Well, hopefully we can do that with just by hand. We won't need quadratic formula. Okay, so let's check it. Isn't this fun? The answer is yes. Well, maybe. Okay, for the 16, let's try maybe 4x, 4x. We could also do 8 and 2. Let's try 4x, 4x. And let's see if we can make the 15 is what, a 5 and a 3. So what if I do a minus 5 and a plus 3, because I should end up with more negatives than positives because we need a negative in the middle. That's going to be negative 20 on the x's and plus 12. Hey, that works. Negative 20 and plus 12 gives me negative 8, right? So let's just double check the FOIL. 4x times 4x, 16x squared, right? Check. 4 times 3 is 12x's, right? 12x's minus 20x's is negative 8x. And then negative 5 times 3 is oh, wait a minute. I should be getting plus 15, huh? Whoops, I guess I gooped up. Hang on a second. Yep, you see the mistake? That's what happens when you work a long problem at 4:30 in the morning. This should have been a minus, because when I copied the result of the division, I just goofed up. It's this minus. Okay, so it does work because negative 5 times 3 is negative 15. Okay, all right. So therefore, I've got 4 factors. Boom. So what are my 4 factors? My 4 factors are boom, 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 and bam, right? Because last one's always different. It's got to be a funny guy. Okay, so my factors are x minus 4, 3x minus 1, 4x minus 5, 4x plus 3. So all of that multiplied together would give me this original polynomial. What are the corresponding zeros? Just set each factor equal to 0. So if you set x minus 4 equal to 0, you'll get x equals 4. If you set 3x minus 1 equal to 0, you'd move the 1 across, divide by 3, 1/3. If you set 4x minus 5 equal to 0, you're going to move the 5 across to get positive 5 and then divide by 4. And if you set 4x plus 3 equal to 0, you're going to move the 3 across, you get a negative 3, and divide by 4, negative 3/4. Okay, and that's it. Those are my 4 zeros of this function. I notice there's always only going to be 4 of them because it's a degree 4 polynomial. Okay, so if I would have continued the hunt, at the next stage when I would have done quarters, I would have found these two. Okay, so I guess hunting wouldn't have been bad either. How would I find those by hunting? Remember, we already found the 4 when we did whole numbers. How do I do whole numbers? Table set, start at 0, delta table of 1, right? Let's just review. Whoops, make a table. Okay, notice at 4, I get a 0. So I would have found that by hunting, okay, on the calculator. Let's hunt the thirds. How do you hunt the thirds? Table set, start at 0, delta table of 1/3. Okay, it converts that to a decimal. Let it do it. Let the calculator convert it to a decimal. Don't type in because you won't put in enough decimal places. Do the fraction. We find x equals 0.333, which is 1/3, right? So we found x equals 1/3. And remember when we found, let me just remind you, when we found x equals 1/3, that way we converted to x minus 1/3 as the factor, and then we multiplied that factor by 3 to clear the fraction. And so we have 3x minus 1 as the factor, right? So we found this. This was by using delta x equals 1. This is delta x equals 1/3. Let's try 1/4, okay? Because remember, when we listed the possible rational factors, the next possible denominator would have been 4. So I go to table set and make my delta table 1/4. Okay, now let's make a table. And let's see, I'm getting a 0 at 1.25, which is 5/4, right? 1/4, 2/4, 3/4, 1 is 4/4, 5/4. So 5/4 is a rational 0, there it is. Okay, and then if I go in the negative direction, there it is right there, negative 3/4. Okay, there we go. So that's another way to do the problem. Fun, right? Let me check it. Yep, I just Googled it, and yep, indeed it is fun.